Assalamualaikum and hi everyone. This video will teach you how to solve rate of change problems by using the quantities or information given by a question. Based on topic 3.1, we understand that a slope is the change in y coordinate divided by the change in x coordinate. Considering change in position over time or change in temperature over distance, we see that the derivative can also be interpreted as a rate of change. In order to solve problems involving rates of change, you can either use the chain rule or implicit differentiation. Basically, there are three basic steps that you have to follow in order to solve rate of change problems. The first step, you need to list all the given quantities and rewrite the problem using mathematical notations. For some problems, it will be helpful that you transform the problem into a sketching. The second step, you need to use the equation that relate with the changing quantities. This may involve sometimes area, a volume, or maybe some other formula. Next, take the derivative to get the relating rates. And the third procedure, or the third step, you need to solve by using the chain rule or implicit differentiation. Here is the list of cases of problem involving rates of change that we will discuss in this lecture video. The same solution approach applied to these cases can also be used to other cases, such as rate of change in parameter, rate of change of balloon height, shadow problem, and so on. However, in this lecture video, we will focus on the main cases as stated here. Now let us refer to examples or questions given in the tutorial question. Refer to tutorial 3, applications of differentiation. Let us first look at question number 12. Question number 12 give you a problem about a circle. The radius of a circle is increasing at the rate of half centimeter per second. So let us transform this sentence into mathematical notation. The radius increasing at the rate. The rates mean we have here, since it is about radius, then we need to write it as dr dt. Suppose that r represents the radius. So dr dt, it is equal to half centimeter per second. Find the rate. We need to find the rate, find the rate of change of the area. We need to find the rate of change of the area. So dA dt. When r is equal to 4 centimeter. We know that the area of a circle A, it is given by pi r square. And from this formula, we can find dA dr because A is in terms of r. So dA dr is 2 pi r. Then we substitute r is equals to 4. So 2 times 4 times pi, which is 8 pi. So what's next? We want to utilize this, and this in order to find dA dt. So in this case, we will utilize the chain rule. So the chain rule will be dA dt equal to dA dr times dr dt. Okay, from the question, we do have the value of dr dt, and we have dA dr is 8 pi, dr dt is half. Therefore, the answer for dA dt is 4 pi. And the unit for this answer will be centimeter square per second. How do we know that it is centimeter square per second? We know that the area is measured in centimeter square because here in the question you have the unit for the radius is centimeter, so definitely you will have the area is in centimeter square. And then the time is measured in second. So therefore, area over time, then we have centimeter square per second. So this is the answer for dA dt. Okay, if you see here, this solution is by using the chain rule. Okay, here using chain rule, because you have the chain rule here. This is the chain rule. You can also solve this problem by using implicit differentiation. Differentiation. Okay. Here we will use, if you want to use implicit differentiation, we will also use the formula A equals to pi r square. So what we will do, we will differentiate with respect to time both sides. Therefore, dt A dt pi r square. And then you will differentiate the variable A, but because this is variable A, but you want to differentiate with respect to t, then what happens? If you differentiate A, you get 1. But because this is variable A, not variable t, then you will have dA dt. And then for the right-hand side, we have the expression is in terms of r. But you want to differentiate with respect to t. You differentiate the variable r as usual. So you will get 2 pi r. But then because we want to differentiate with respect to t, then you will have times with dr dt. And we know that we want to find dA dt. Then what happened? 2 pi times r is given, it is equal to 4. So this is our r here. We will use the same information. So times 4. And then times dr dt is half. So you'll get here 4 pi And we know that the unit is centimeter square per second. So either you use the chain rule or implicit differentiation, you must get the same answer. Okay, now let us look another example. Okay, this example is based on question number 16. We have here a spherical problem. The volume of a spherical balloon is increasing at a constant rate, volume, and the rate is 0.05 meter cube per second. So that's mean from the first sentence we have, okay, I'll show it to you how we want to use I'll show you how we will use the chain rule first. Okay, from the first sentence, you have the volume increasing at a constant rate, 0.05 meter cube per second. So since it is about the rate of the volume, then that's mean we have dv dt. Let's say that volume is represents by v, then dv dt, it is equals to 0.05 meter cube per second. The second sentence, find the rate of increase of its radius. Find rate of increase of its radius. So find, what you need to do is, you need to find the rate of increase of its radius. Let's say radius is represented by r. So find dr dt when the volume v is when v is equals to 0.008 meter cube. Given volume of a sphere, it is equal to, you have v equals to 4/3 pi r cube. And from this formula, we can find dv dr because v is in terms of r. So we can find dv dr, where dv dr is 3 times 4/3 times pi r square, where this is equals to 4 pi r square. Okay, now we want to utilize this, and this. Okay, we want to use the chain rule, so we will utilize these three, where we have dv dt, it is equals to dv dr times dr dt. Okay, we have dv dr is 4 pi r square, and then we have dv dt is 0.05, and dr dt is the one that we want to find. So we know that we want to find dr dt when v is 0.008. Therefore, we substitute we will substitute dr. Oh, I'm sorry. We not yet have the value of r. So we need to find the value of r. We know that the volume, the formula for volume it is equal to 4 over 3. Sorry, this is volume is 4 over 3 pi r cubed. And given that the volume is 0.008, therefore we can find R. And when you use your calculator, you'll find that, you find that R, it is equal to 0.124. Okay. From there, then we will substitute R into here. So what happened? We have 0.05 equals to 4 pi r square is 0.124 square times dr dt. So from here you can find dr dt. It is equal to 0.258 if you round off to 3 decimal places, where the unit, because R is measured in meter and the time given for the problem is seconds, so meter per second. So that is if you use the chain rule. So now let us look what if we want to use the implicit differentiation. Okay, if you want to use the implicit differentiation, we will utilize the formula for the volume of the sphere, which is V, it is equals to 4 over 3 pi r cubed. And then we know that we want to find dr dt, so we will differentiate with respect to t for both sides of the equation. So d dt v and d dt 4 over 3 pi r cubed. Therefore, we have, for the left hand side, you differentiate the variable v as usual. When we differentiate v, we get 1. But because we want to differentiate with respect to t, but the expression we differentiate is v, then we have dv dt. And then for the right hand side of the equation, we have the expression in terms of r, but we want to differentiate with respect to t. So what you have to do, you differentiate the expression as usual, like you differentiate with respect to r. So we have 3 times 4 over 3 pi r cubed. And then because we have to differentiate with respect to t, so what happened? You will have times dr dt. So what's next is, we know that we want to find dr dt. Sorry for this part. Okay. We want to find dr dt, and we know that, okay, of course you need to include this also in your solution. And based on this, we know that R is 0.124. So what you have to do next is you just substitute R equals to 0.124 into this equation. So dv dt is, we know that it is 0.05. So then we have 4 pi, r is 0.124 Sorry, this one should be, I made mistake just now here. This is supposed to be r square, not r cube. So 0.05 equals to 4 pi times 0.124 square dr dt. Then you can find dr dt. It is equal to 0.258. The same answer as what we have by using the chain rule. Okay, next, we want to look at a cylindrical problem. Okay, this example is not in your tutorial question. I took it from somewhere else, but I hope this example will be helpful for you. So let us look at the question. If a cylindrical tank with radius 5 meters, we have here a problem about a cylindrical with radius. Do you know what is cylinder? Let's say we have a cylinder is like this. Okay. It has a radius 5 meters. So this is R. Let's say R is radius. The radius 5 meters. R equals to 5 meter. Is being filled with a water at a rate of 3 cubic meters per second. So we have here 3 cubic meters per minute, not per second, 3 cubic meters per minute. And then here it says that filled with water. That means this 3 cubic meters per minute, we have the value is 3 cubic meters mean meter cube per minute, where this value is actually represents volume. Sorry, not volume, per minute. This is actually the rate of the volume, dV dt. So how fast is the height? How fast means the rate. This is rate. What is the rate of the height? Let's say height is represented by h. So we have h is here, the height of the cylinder. So height, how fast is the height? So what actually we have to do here, we need to find dh dt when given that r equals to 5 and dv dt is 3 meter cube per minute. And we know that the volume of a cylinder, it is equals to pi r square h. Okay, you can find this formula, the volume formula for a cylinder from page 47 of your formula book. So what's next is we will substitute the value r equals to 5. So pi 5 square h, it is equals to 25 pi h. And you see that. Okay, now I will show first how we want to solve by using the chain rule. So if you want to use the chain rule, what we will do is because we already have v equals to 25 pi h, where v is in terms of h, then you will need to we can find dv dh, where dv dh is 25 pi. And then we want to utilize these three terms, dv dt, dv dh, and dh dt. We will put these three into a chain rule. So we will play around so that it will form a correct chain rule. And here we have dv dt. It is equals to dv dh times dh dt, where dv dh is given by 25 pi, dv dt is 3, and dh dt is the value that we want to find. Therefore, dh dt, it is equals to 3 over 25 pi. And since h is measured in meter and the time is measured in minute, therefore we have dh dt, the unit is meter per minute. So this is our final answer. Okay, if you want to use the implicit differentiation, so we will also use the same formula for the volume of the cylinder, which is V equals to 25 pi h obtained here. Then we will differentiate with respect to t both sides because we know that we want to find dh dt. So d dt, V, d dt, 25 pi h. So for the left hand side, we have dv dt. And for the right hand side, since the expression is in terms of h, you differentiate as usual, like you differentiate in terms of h, but actually we want to differentiate with respect to t. So what happened on the right hand side, you will have 25 pi, but because we want to differentiate with respect to t, then 25 pi must be multiplied with dh dt. Then we know that dv dt is 3, so we substitute 3, 25 pi, dh dt, therefore dh dt, it is equals to 3 over 25 pi meter per minute. Okay, see, it doesn't matter whether you use the implicit differentiation or chain rule, you will get the same answer. Okay? Same. Okay, now let us look again to your tutorial 3 question. Now we look at the question number 17, where in question number 17, this is a problem involving cone. So let us look what are the information given to us. Water is poured into an inverted right circular cone. We have right circular cone. So it is something like this. You have a cone, inverted cone, and then we pour water, and then the cone, it has a radius at the top. So this is, sorry, it has radius r is 5 meter. So, and then we have where r is 5, And then we have the depth of the cone, where the depth of the cone is given by this. Let us denote it by h. Then we have h, it is equals to 8. Sorry, not 8. It is 10. So water is poured. Sorry. We have here 8 meter cube per second, where this value, okay, water is poured, and this is the value. So that means that is the rate of the volume of the water poured into the cone. So that is the value of we have dv dt. Okay, another clue that we know that this is dv dt because meter cube is the unit for volume, and this is per second. So dv over dt. Find the rate at which, so what we want to do here, we want to find the rate at which the depth, that's mean dh dt. So find the h dt of the water is increasing when the depth, which is h, is 4 meter. So based on the formula for the volume of a cone, where you can refer it from your formula book, okay, given that you have formula for volume is V equals to 1 over 3 pi r square h. Okay, this formula you can find it from page 47 of your formula book. And this formula, we have two variables. So we need to transform it so that only one variable left. So what we will do, we will use these informations. R equals to 5 and H equals to 10. And we have here, okay, R over H, sorry, we can write this because the ratio of R, the ratio R over H, it is equals to 5 over 10. And from here, we can get that R, it is equals to, because this is 1 over 2. So that's mean we have R is H over 2. And we just now know, we just now have that the volume, it is equals to 1 over 3 pi R square H. So what we will do next is we will substitute R. We have V, it is equals to 1 over 3 pi R square H. We will substitute R equals to H over 2. Then we have 1 over 3 pi H over 2 square times H, where this is equals to 1 over 12 pi H. Oh my, apologize. 1 over 12 H cubed pi. So now our formula for the volume, only one variable left for the right hand side. So what we will do next is we will differentiate with respect to H, because now V is only in terms of H. So we can find dV dH. where dvdh is 3 over 12 pi h square, where this is equal to 1 over 4 pi h square. So what's next? We want to utilize this, and this. Oh, just now I left this one. I left one more information, sorry. We know that dv dt, based on the question, it is equals to 8 meter cube per second, where this one. So here, then we want to put this dvdh, dvdt, and dhdt into a chain rule. So what we'll have next is dv dt, it is equals to dv dh times dh dt. Okay. Sorry, I should write it here so that you won't get confused. So this is by using the chain rule, where dv dt, it is equals to dv dh times dh dt. We do have the value for dv dt, which is 8, and dv dh is 1 over 4 pi h square, and dh dt is the value that we want to find. And we want to find dh dt when h is equals to 4. So we will substitute h equals to 4. 1 over 4 pi 4 square dh dt. Therefore, dh dt, it is equal to 2 over pi meter per second. How do I know that the unit is meter per second? Because h is measured in meter, and then time is measured per second. So meter per second. Okay, next, I'll show how we want to solve by using implicit differentiation. Sorry. Okay, we still use the same information until from here to here, and then from here we will go to implicit differentiation. Then what happened? Sorry, not from there. From here only. Until here, we will go to implicit differentiation, where we have v, it is equals to 1 over 12 h cube pi. So what we will do, we know that we want to find dh dt. Therefore, we will differentiate with respect to t for both sides of the equation. So d dt (1 over 12 h cube pi). So the left hand side is dv dt. Okay, the right hand side is in terms the expression here. It is in terms of h. Therefore, we will differentiate as usual with respect, like we differentiate with respect to h. But what happened? You will have 3 times 1 over 12 pi h square. And because we want to differentiate with respect to t, then this 3 times 1 over 12 pi h square, you need to multiply it with dh dt. Okay. So then you substitute dv dt given in the question. It is 8. And then we have here 1 over 4 pi, and then h squared. H is, sorry, where is h? H is 4. We want to find dh dt when h, as stated here. We want to find dh dt when h is 4. So 4 square. 4 square dh dt. Then you'll find that dh dt, it is equal to 2 over, sorry, 8, 4, because this one can be cancelled out. So 2 over pi meter per second. Okay, if you see here, sorry, we get the same answer. Okay, so this is the answer if you want to use the chain rule, and this is the answer if you use the implicit differentiation, and both will give the same answer. Okay, next we want to refer to tutorial 3 applications of differentiation, question number 27, where this is about a ladder problem. Okay, here we have a ladder 9 meters long leaning against a wall. Okay, let us put this problem into a sketching. So what we will have here, let's say this is the wall. Okay, and then we have the ladder, sorry, the building, the wall of the building. And then we have a ladder here. This is the ladder. And it is 9 meters long. The bottom of a ladder is pulled along the ground away from the wall at a constant rate. We have here, sorry, the bottom of a ladder is pulled along the ground away from the wall at a constant rate of 1 meter per second. Okay, now let us assume that the distance from the bottom of the ladder to the wall is represents by x. Sorry, I'll write it in blue. X, and the distance from the top of the ladder to the ground is y. Okay, based on the second sentence, we have the bottom of a ladder is pulled along. So that's mean you have the ladder is pulled along the ground away from the wall at a constant, because when you pull like this, then what happened? Then the ladder will, the bottom will, the y value will decrease and the x value will increase. So because the x value, when you pull, then the x value will increase, then the value that you have here, 1 meter per second, where this is dx dt, one meter per second, it is a positive value, because when you pull, then x increase. If you push, then when you pull away from the wall, then the x value increase. That means the x dt is a positive value. But if I change the question that the bottom of the ladder is pushed to the wall, then the x will increase, then the x dt value the x value will decrease, then the x dt value will be a negative value. But in this question, we have the x dt is positive because when we pull, then x increase. So the x dt is positive 1 meter per second. So, and then the next sentence of the question, how fast? So how fast means this is about rate. Will the top of the ladder be falling when the ladder is 3 meters away from the wall? So how fast will the top of the ladder? So it is actually means that we need to find dy dt, because how fast will the top of the ladder will be falling? So it is about the y variable. So the rate of y change with respect to time. So dy dt when the ladder is 3 meters away from the wall, when x is equals to 3. So what's next? We have okay. Now we need a formula. So what do you think? Okay, if you see here, we have a triangle problem. It is actually we need to utilize the Pythagoras theorem. Okay. Sorry. Okay, based on the Pythagoras theorem, we have x squared plus y squared. It is equals to 9 square in this case, because our the length of the ladder is 9 meter. So x squared plus y squared equals to 9. And then what we have to do, we know that we want to find dy dt. So what we will do, we will differentiate both sides with respect to t, where in this case we will use the implicit differentiation, d dt x squared plus y squared d dt 9 squared. So for the left hand side, you differentiate x squared. So we have 2x, because x squared is we want to differentiate with respect to t, but our expression is x squared. So what you have to do is you just differentiate as usual 2x, but then you will have dx dt plus, and then we will differentiate y square as usual, 2y, but because it is in terms of y, but in this case we want to differentiate with respect to t, then what happened, then you have 2y times dy dt. And on the right hand side of the equation, we have 9 square, which is a constant. If you differentiate any constant, it will be 0. So what happened next? We know that we want to find dy dt, and we do have the value of dx dt. So substitute into the question 2 times, and we also have the value of x, which is 3, because we want to find dy dt when x equals to 3. So substitute x equals to 3 times 3 times dx dt is 1 plus 2y. Okay, dy dt is the one that we want to find, equals to 0. But if you see that in our final part here, we still have the variable y. So we must have the y value in order to find dy dt. So what we will do, we will utilize the Pythagoras theorem. Okay, you have x squared plus y squared equals to 9. And we know that we want to find, sorry, we have x squared plus y squared equals to 9. We know that we want to find dy dt when x is equals to 3. Therefore, we will substitute x equals to 3. So 3 squared plus y squared, y squared, this is equals to 81. So 81 minus 9 is 72. So y squared is equals to 72 and y is equals to plus minus 8.5, around 8.5. Okay. This is approximately plus minus 8.5. But then what we have to do next. Okay, now we have y, and in this case we just take the positive value because y shouldn't be a negative value. So we will substitute y equals to 8.5 into here. Then we have here 6 plus 2 times 8.5 times dy dt equals to 0. So we have here 17 dy dt equals to negative 6. Then you will have dy dt. It is approximately negative 0.35. And since y is measured in meter and t is measured in second, so the unit for dy dt is meter per second. So this is the answer we are looking for. Okay. And if you see here, the value of dy dt that we have is a negative value. This is consistent with the problem where when y is, because the y value is decreased when the ladder, when the top of the ladder move to the bottom, move downwards. Okay? So it is a negative value. And this will be our final example for this lecture video, which is about the motion. Okay, when a ball is thrown straight up in the air. Okay, this example is actually based on not from your, this example is not from your tutorial, it is from your lecture slide. I just I take it to explain it here because maybe you don't really understand what is actually how actually we want to solve the problem. Okay. So when a ball is thrown straight up in the air, its position may be measured as the vertical distance from the ground. So you have somebody will throw up the ball. Let's say throw like that, and then it will fall down. Okay. When a ball is thrown straight up in the air, its position may be measured as the vertical distance. I'll increase this one. When a ball is thrown straight up in the air, its position may be measured as the vertical distance from the ground. Regards up as the positive direction, and let ST be the height of the ball in feet after t second. Suppose that ST is negative 16t squared plus 128t plus 5. What is the velocity after 2 seconds? Okay, before we proceed with the solution for A to D, let us look I want to explain first the concept of motion, a simple concept of motion that you have actually learned in secondary school, or in matriculation, or maybe in diploma. And what we have, the formula for velocity, it is equals to displacement over time, where this is equal to final position minus initial position over final time minus initial time. So if we let S as a position, then velocity, it is equals to SI minus SJ, where SI is the final position and SJ is the initial position, over TI minus TJ. Okay. So what actually happened in this formula, the numerator, which is SI minus SJ, is the difference in the object's position. Sorry. And then we have the denominator is the difference in time, where this is actually ds dt. Okay. So if you have S, which is the position, and in this question we have S is given by negative 16t squared plus 128t plus 5, then if you find the SDT, that means the SDT is the velocity. So that is the concept how actually from S, then we get V, which is the velocity. So question A, we want to find the velocity. So what we'll do is we will find the S dt. So we will differentiate S with respect to t, which is negative 32t plus 128. And for question A, we want to find the velocity V after 2 seconds. So we will substitute t equals to 2 into this result. So negative 32 times 2 plus 128, where it is equals to 96 sorry, 128, not 96, it is 64. 64. And since S is measured in feet and T is measured in seconds, so we have the answer, the unit for the answer is 64 feet per second. Question B. Okay, I'll copy this question. Sorry. Not yet finished. Sorry. I thought that it will be finished after this. Not yet. Paste. Okay, we'll have it. Because we want to solve question B now. So for question B, okay, just now we have that V or the S dt. It is equal to negative 32t. This is based on question A, negative 32t plus 128. Then we can find the acceleration A by finding dv dt. So dv dt is negative 32. And even though you are given that the t is 2 seconds, in this case, this value 2 seconds is not is not used here because we have dv dt is a constant. So A is negative 32, and since volume is measured in meter per second, sorry, not meter, feet per second, and then we have t is in second, therefore we have the unit for acceleration is unit is feet per second power of negative 2. Sorry, second square. No, I shouldn't. Feet per second power of negative 2. Alright, next question C. At what time is the velocity is negative 32 meter per second? So just now we know that our velocity is negative 32t plus 128. So we want to find the velocity, the t when the velocity is negative 32. So negative 32t plus 128. Therefore, we have here 32t equals to 128 plus 32, which is 32t, 160 Therefore, T is 5. T is measured in seconds, so 5 seconds. Okay, question D. When is the ball at height 170 meters? So this is about the height. Height is actually the S in this question. Just now from the question, we have S here. It is equals to negative 16t square plus 128t plus 5. So for question D, we have S equals to negative 16t square plus 128t plus 5. And we know that from question D that S is 117. So we will simplify this first. Therefore, we have here 16t square minus 128t plus 117 minus 5 is 112. Right? Okay. But then we will factor out 16. We'll see first. 16 t square minus 128 divided by 16 is 8. So 80 plus 112 divided by 16 is 7. So what's next is we can eliminate 16. So what's left is t square minus 8t plus 7 equals to 0. And then we have, okay, I will copy first this part. Let us bring this, sorry. Sorry. Okay, just we will continue here. And from here, we can factorize the equation so that it become t 1 times 7 minus minus. Thus, t is equals to 1 and 7 seconds. Okay, that's mean actually we have 1 second and 7 seconds. Okay. Okay, if you see here, we have two answers for t. Okay, why? Maybe I can add another question in this problem. Question E. Why is that we have two answers in question D? Then you have to explain. So what actually happened when a ball, okay, just let us see the problem. When a ball is thrown straight up in the air, its position may be measured as the vertical distance. So here, when a ball is thrown, we throw away a ball. And then what happened? Let's say this is the ground. Oh, sorry. Okay, and then we have here. It's not supposed to be like that. Okay, we throw away and then it will fall back to the ground, right? Okay, when you throw from the ground, and then here, this is where, let's say, 117 meters, feet. In this case, we have the, if I'm not mistaken, yes, in feet. 117 feet from the ground. Then this, the first time when you throw the ball, the first time it reached 117 meters, this is when t is equals 1 second. Okay, and then it will go away again, go up, reach the maximum, and then go down, and then again it will reach 117 meters here. So this is when it reach here, this one, then this is where when t it is equals to 7 seconds. Okay, so this is how this is why we get two answers for question D. So I guess that's all the examples for topic 3.2. So I hope that you will do your exercises. Don't wait until you don't have time to do revision. Okay, please refer to the tutorial questions, and you also have extra or more examples from the lecture slides if you don't have your module. And if you have problem, you may ask your lecturer. We are happy to help you, inshallah. Okay, thank you.